We have steady state analysis అంటే ఒక సిస్టమ్ దాని స్టేట్స్ని వి అనలైజ్ చేస్తాం. అంటే ఫర్ ఎగ్జాంపుల్ ఫస్ట్ మనం ఇందాక చూసాం వాట్ ఈస్ ద స్టడీ స్టేట్ ఎర్రర్. Steady state error is a measure of the accuracy of the system. Ante it is the difference between action output and the desired output. So steady state error manki ochindi ante we obviously we have an actual output. So steady state error vaste we can find out what is the desired output. Based on this manam aa system enta varaku stable anedi telusukochu. Dani stability ni manam we can tell about its stability. So steady state analysis lo basically what we do is we find out certain coefficients like steady state error, some static error coefficients. Ivanni telusukoni we finally comment on its stability anamata, so that we can decide whether this system can be designed or not. So steady state error kosam we have a derivation here. Consider first oka system consider cheyadam. Okay, input we are giving R of S. Tarvata we are giving E. This is becoming E of S because the error signal. The transfer function of this block is G of S and the transfer function of this block is H of S. Feedback loop idi. And we have controlled output C of S. We get B of S here. Ikkada minus symbol unte. Yeah, this is the positive feedback system. So E of S is nothing but error signal anamata. E of S is the error signal and B of S is the feedback signal. So from this figure manaku ardhamayyedi enti E of S is equal to R of S minus B of S, because ee summing point daggara we are calculating the sum of R of S and minus B of S. Ee renditni calculate chesi we are giving it as error signal. Aa error signal malli deeniki input ga velli it's giving out a controlled output. So E of S is R of S minus B of S, but B of S is the output of H of S and H of S ki input enti C of S. So we can say B of S is equals to C of S into H of S, because B of S ane output C of S and H of S combined ga వచ్చే వీటి effect వల్ల we are getting B of S. So B of S can be the product of C of S and H of S. ఇది తీసుకెళ్ళి ఇక్కడ substitute చేసుకుంటే we get E of S is nothing but R of S minus C of S into H of S. But we have another point which says C of S is equal to E of S into G of S. Similar way, B of S is equals to C of S into H of S and ela cheppamu. C of S is equal to E of S into G of S. Endukante C of S is the output here, E of S is the input and G of S is the process. So output will be equal to input and the process, right? So we get product of E of S and G of S is equals to C of S. So malli dini ee equation lo substitute chesinappudu E of S will be equal to R of S minus E of S into C of S into the G of S into H of S. So ee equation ni manam simplify cheskunte we get E of S is equal to R of S by 1 plus G of S into H of S. Here H of S is nothing but feedback element. If this feedback element becomes unity, then the unity feedback loop antam. Appudu E of S will be R of S by 1 plus G of S. Idi unity feedback. Idi non-unity feedback ki, idi unity feedback. So E two formulas use cheskoni we find out the steady state error. E of S is nothing but error. మనకి స్టడీ స్టేట్ ఎర్రర్ కావాలి అంటే E of S is present in Laplace domain. దీని Laplace domain లోంచి టైం డొమైన్ లోకి కన్వర్ట్ చేయాలి. కన్వర్ట్ చేయడం కోసం స్టడీ స్టేట్ ఎర్రర్ ESS will be equal to limit t tends to infinity E of t. Because steady state of a system is a state at which time is infinity. So at a steady state manaku vache error calculate cheyadam kosam t is equals to infinity తీసుకున్నా. So we have a theorem called final value theorem in Laplace transform, which says limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s, where f of s is the Laplace transform of f of t. So ikkada we have limit t tends to infinity e of t. This can be limit s tends to 0 s into e of s. E of s is nothing but Laplace transform of e of t. But ikkada manaki e of s formula we got it long back as e of s into e of s is r of s by 1 plus g of s into h of s. So finally the steady state error ESS will be equal to limit s tends to 0 s into r of s by 1 plus g of s into h of s. So e formula based cheskuni, this is nothing but a steady state error. Elanti input kaina e steady state error formula is the final formula. So for different inputs e formula keeps on varying. For example, for a negative, ఇప్పుడు ఇది negative feedback system kabatti we are using a positive sign here. For a positive feedback system we use a negative sign in the denominator. So for different kinds of inputs, effect of input అనేది study చేస్తే effect of input అంటే ఈ input change అయినప్పుడు, for example first step input consider చేద్దాం. Step input ki, as we have seen earlier, r of s is a by s. So ee value మనం ఇక్కడ substitute చేసినప్పుడు we get ESS is equals to a by 1 plus limit s tends to 0 g of s into h of s. After simplification we get this part. R of s equals to a by s ni ee particular formula equation number 1 అనుకుంటే దీన్ని equation number 1 లో if we substitute that ఇది a by s అవుతుంది. ఇక్కడ s s cancel అయిపోయి ఈ లిమిట్ ని ఇక్కడికి ట్రాన్స్ఫర్ చేసినప్పుడు finally we get this equation. ఈ ఈక్వేషన్ లో this part it depends, it is a unique property of a system. So limit s tends to 0 g of s h of s ఇక్కడ ఎక్కడ input effect లేదు దీనిపైన. So it is a unique property of a system and this is called as positional error coefficient. Positional error coefficient, which is denoted by Kp. So finally ESS will be equal to a by 1 plus Kp. For step input, we have the steady state error coefficient, steady state error as a by 1 plus Kp, where Kp is equal to this limit s tends to 0 g of s into h of s, called as positional error coefficient of a system. This is constant for a given system for any input.